Hey, good evening, guys, and welcome back, everybody. And I'm so sorry for the last 2 days, right? Little exhausted with my personal things. Okay, let's get started, right? So we have done with the OSPF protocol. So only one thing was remaining, if you guys remember that. That was called as the OSPF state, right? So normally, most of the time, you have seen that this OSPF states, normally people are started with the initially, but I love to give the OSPF state information the last. The reason is that you must need to know everything about the protocols. Then you can go through the OSPF state. It will become very easy to understand about, right? So the first state of the OSPF I talk about, we have a down state, right? So in a down state, what happened basically, my neighbor is down, right? And we are not able to exchange, right? We are the routers doesn't exchange any hello packet. So it's a normally interface is down. Basically, we can say that. So take example, we have router number one. Understand this concept. We have router number one, we have router number two over there. And this is the 0/0 interface. This is the 0/0 interface. So we are not sending any kind of hello packet. This is totally down. That's called the down state. Next state we have after that, what happened? We have an init state. It's called as an initialized state. In this init state, basically what happened? Router received the hello packet from its neighbor, right? Router just received the hello packet from its neighbor. So for example, if I'm going to up this interface and understand the concept, we have enabled the OSPF protocol of it. Take example as the IP OSPF number one, area 0, and same thing I said the IP OSPF number one, area 0. So what happened? This particular interface will be enabled in the OSPF routing protocol, and now both the router is going to exchange the hello packet. So take example, when the router number one is going to send the hello packet to the router number two, right? Then what happened? Router number two will move in the init state. Same thing, what happened? Router two is going to send the hello packet to router number one. It will move in the init state. So in the normally init state, what happened? Both the router is going to receive the hello packet. That's all, nothing else. So it means that it's called as a unidirectional state. Why I call it a unidirectional? Because we are just receiving the hello packet from its neighbor. So router one does not have any idea. Try to understand. Router one is going to put the router ID 1.1.1 in this hello packet. Router two is going to put the router ID 2.2.2 in this hello packet. They're not going to say that, hey, I have received your own hello packet. Understand the concept? He put the own router ID. He put the own router ID in the hello packet. So router one has just sent it. Router two has just sent it, but nobody has an idea that my hello packet has received by the router number two, and router two has no idea my hello packet is received by the router number one, right? We just send it. So you can say there is no reliability is happening right now. So that's why we have another state we have. It's called as a two-way state. If you see the name itself saying that what, in the two-way state, what happened? Both the router know each other. And how they will know each other? So in that case, what happened? Now the next hello packet, it will send like that way. So router 2 will send the next hello packet. In this hello packet, he will say that, hey, my neighbor is one. Now, the hello packet that is sent by the router number 2, he will mention the router ID of the router number 1. Same thing, what happened now? When the router number 1 is going to send the hello packet to the router number 2, he will mention the router ID of the router number 2. So when the router number one is going to send this hello packet to the router number two, router number receive this hello packet and say that, hey, this is my router ID. It means that router one knows about me. Same thing when the router number two is going to send this hello packet. What router number say that, hey, this hello packet contains my router ID. It means that router two knows about me. That's why it's called as a bidirectional state. Right? Another thing about the two-way state is what? In this state, your DR, BDR will be elected. Then next state we have is what? Next state we have X start state. Remember, if you guys, I explained you the concept of the master and slave and the MTU mismatch, right? So normally in the X start state, what happened? Now both the router, now the routers are ready to exchange the database information, right? In this state, right? Master and slave will be elected. right, ready to exchange, but we are not exchanging it. In the finally, in the exchange state, what happened, right? Now we are gonna exchange the database information. We can see the LSDs, we are gonna exchange it, LSDB table. So router one is gonna share the own LSDB table to the router number two, and router number two is gonna share the own LSDB table to the router number one. So both the router has a LSDB table that contains the LSA's information over there. Both the router has a LSDB table, they contain the LSA's information. So now the router one is gonna share the own LSA database table to this guy. Router two is gonna share the own database table to the router number one. And then finally, what happened? Once try to understand, try to understand what happened when the router, right? When the router number one receive this LSDB information, when the router number one is going to receive this LSA information, what a router one will do that? It will install this information in the own LSDB table. Same thing what happened when the router number one has shared this information, this LSA's information to the router number two. Router number two is going to install this LSA's information in the own LSDB table. So installing the information is called as a loading state. So in the loading state, what happened? We are installing, or we can say that downloading the database information. And then finally, we have what? Full state. Full state means what? Now we have downloaded. I'm so sorry. Now we have downloaded the information. It's time to give acknowledgement by sending a ls acknowledgement packet. Right? So understand the concept, what's happening over there. In the down state, there is no any hello packet exchange. In the init state, what happened? Router is going to exchange the hello packet, but there will be no router ID mentioned in the hello packet. In the two-way state, what happened basically, router is going to exchange the hello packet, but in that hello packet, the router ID as mentioned. That's why it's called as a bidirectional state. In this state, the DR BDR will be elected. Till this point, what we are doing that we are only doing the hello packets. In the Xstart state, what happened now? In Xstart state, we are going to deal with the DVD packet, right? And LSR packet. And then we have a exchange and loading is going to deal with the LSU packet. And once the LSU will be done, then finally we have to give the acknowledgement packet. So this is how your OSPF states are there, guys. So most of the time, you will get this, questions in an interview. So recently, I'll tell you one thing. Recently, one of my students went for the like an Amazon interview, right? I think so yesterday or maybe day back yesterday. So he called me yesterday. I think so yesterday he gave the interview. So he called me that and he gave the interview in the profile of ND, right? Network development. So this is the famous profile in the Amazon. So they started the question from the Python, of course, right? Because it's a scripting language and most of the time, you need to know the Python if you are, because the guy who gave the interview, he has experience of more than 8 to 10 years, some near around. Okay. He's working for the Cisco right now, but he gave the interview in the Amazon and he cleared the first round as well. He has another round. But after the Python, right, the guy has asked the question from the OSPF states only. So the question was, in which state the master election is happened? In which state the MTU information is there? What happened if the MTU is a mismatch? If the MTU will mismatch, you will get stuck in the Xstart state. In which state the DR BDR will be elected? In this state. In which state the router can see the own router ID? In the two-way state only, right? In a full state, basically, we are going to download all the information over there, right? So these are the questions you may encounter. So normally, and the basic level, if you go like a 3 to 4 years of experience, they just ask you, hey, could you please explain me what is OSPF states, right? And what are the OSPF states we have? Apart from this state, right? Apart from the down, init, two-way, Xstart, exchange, loading, and full. Apart from this states, we have another state is known as a two-way state. Not two-way state, sorry, attempt state. So why I haven't discussed this state? The reason is that because this state are only comes in the picture when you're gonna do the frame relay concept, which is the very older technology we are not using. That's why you will not see this state nowadays, right? So mainly you will encounter this. So if somebody will ask you, hey, apart from this thing, is there any states are there? Yes, we have a state that's called the attempt state, right? Don't confuse one thing. It's very important to all of you guys. OSPF states are totally different than the interface state. OSPF interface state, if you remember that, in the OSPF interface state, whatever the states comes in the picture, you will have a down state, you will have a point-to-point state, you have a DR, you have a BDR, you have a DRO, right? And anything else? Down, point-to-point, DR, BDR, DRO. One more was there, man. Was that? Okay, let me check it. I have the RFC open. So both are a different thing. Don't confuse with the states, right? So OSPF states are different thing. Interface states are different thing. So RFC 2328. So basically you will not find the information in the normal books. So you have to go with RFC. So RFC version 2, 1998. So interface, let me. Yeah, here we go. States. Okay, so here we see that these are the interfaces still we have. It's a down, and then okay, the loop back. I forget the name. Loop back was there. So let me write on this thing. So I'll write over here. Loop back, down, loop back. Then we have a DR, then we have BDR, then we have a DRO, and then we have a point to point. Anything else? Waiting, yeah. The waiting DRO backup and DR. That's all. So these are the states we have, and that's called the interface state, right? This is called the interface state. Let me put it this guy on the downside. So most of the person, right, have a confusion with this thing. Okay, what is this now? So these are the interface OSPF states. And another one that we have seen till now, OSPF neighbor state. Just we have seen, right? That's down, init, two-way, right? What do we call now? Start, exchange, loading, right? So these are the basically we have a OSPF states. Down, init, two-way, start, exchange, loading. Yeah. So don't confuse with the name. So it's totally different than this one. It's a neighbor state. It's an interface state. So understand the one concept, right? If I'm gonna understand this way, so if there are one, I just enable the OSPF on this particular interface. Take example, I just configure the OSPF on this particular interface. Then what happened? Your neighbor state, right? Your neighbor state never comes because we don't have a neighbor over there, but these state comes in the picture. So it will go have a down, loop back, whatever the. So if you're gonna configure as a loop back, like for example, this is the loop back interface 1.1.1. If I'm gonna configure the OSPF on this particular interface, then the state will be called as a loop back. Of course, if the interface is down, then it becomes in the down state. If the interface is the DR, then it becomes in the DR state. If the interface is the BDR, it becomes in the BDR state. If the interface, there is no DR, BDR, of course, it will go with the DRO. And if you're going to change the network as a point to point, then it will come to the point to point. And of course, in the initially, it will go with the waiting state if the network is a broadcast and non-broadcast. All good, guys? Anyone has a questions?
No, sir.
Great. So that's all about the OSPF version 2 RFC 238. So if you're gonna read the more information of the OSPF Pro, if you really want a detailed information, then go through this RFCs. But right now, if you are a fresher, then don't need no need to learn this OSPF RFC stuff. Okay, because it has a lots of technical information. Then better to watch the video that I have explained you because I have covered each and every point. Okay, so better to learn, go through that video, do the practical. That's a very, very important one. But remember the RFC number 2328, it's help you in a interview. The reason is that I'll tell you, when you go for the interview, right? So whenever the JD comes in the picture, like a 4 to 5 years of experience. So normally in the JD, you will see like this way, OSPF, and they will mention that 2328. So on that time, right, don't be get confused with the what is now 2328. So it's a basically RFC of the OSPF protocol. So there is a mini RFC of the OSPF. This is the one of the famous RFC. So OSPF version 2, that's gonna 2328. It comes in the 1998. Okay, right? Now, okay, so amazing. We have a routing protocol, guys. Like, we have a static routing. So basically, if I talk about the static routing all have a manual behavior. So if you have 100+ network, right, then you have to define the 100+ manual route. That's one of the biggest disadvantage of the static route. Scalability perspective, static route is not a good. Reliability perspective, if I talk about, again, it's not a good, right? But if I talk about the what we call load perspective, how much load is getting on the router side, it's very minimal. So static route has their own pros and own cons as well. But because of the security issues, we came with the we come with the dynamic routing protocol. In a dynamic routing protocol, if you remember that we have gone through the overview of the RIP protocol, right? Routing information protocol. RIP has a problem. What is the RIP problem we have? Right? If you talk about the RIP problem, RIP has a problem is a maximum. We have a 15 hop count. That's the maximum one. Another problem is a slow routing protocol and UDP based protocol, right? That's a one issue. So let's remove this guy because most important focus is what? It's a UDP based protocol, right? If I talk about the in a RIP protocol, if I'm going to manipulate that out, how do you going to manipulate that out? Based on the hook count, right? If you are a very good like an expert, then you can go with the summarization. Based on the summarization also you can manipulate that out. You can change the AD value, you can do that, right? Then another thing what you can do in the EIGRP protocol, either you can change the delay, either you can change the bandwidth, right? And I also explained you the offset list concept, right? And I told you that which one is the recommendation one as well, right? You can change the AD, you can do the summarization as well, right? Based on this way, you can manipulate the route. Again, if I talk about the EIGRP protocol, EIGRP is a IP-based protocol number is 88. So this is the UDP-based protocol, and this is the IP protocol. Next one is what? If you go through the OSPF routing protocol, OSPF, what we have seen that, OSPF, it's an IP-based protocol again. The protocol number is 89. It's a layer 3 protocol. How are you going to manipulate the route? X cost, change the cost. You can do the summarization. You can do that. You have a route preference. If you remember that O and OIA, E and E2, N1 and N2, right? We have a route then also we have an AD concept, right? But still, OSPF is what? IP-based protocol. What do you think about the IP and UDP? First, talk about the reliability perspective. UDP is not a reliable protocol, right? UDP is not reliable protocol. How about the IP? IP is also not a reliable protocol. And that's why we came with the ICMP, right? That's why we came with the ICMP. IP is not a reliable protocol. Okay. OSPF is a reliable protocol. IP is not a reliable protocol, right? In a OSPF protocol, what happened? We have a concept of the sequence number. We have acknowledgement number. EIGRP, we have a concept of the sequence number. We have acknowledgement number. So that makes the protocol reliable. Understand the concept, guys. That makes the OSPF protocol reliable. That makes the EIGRP protocol reliable. UDP is a pure unreliable protocol. It doesn't have any concept of the sequence number, acknowledgement number. Do you really think that these protocols are too scalable to run on the internet side? The protocols that you have seen, the static route with EIGRP, these all are called as what? These all are called as the interior gateway routing protocol. I can call this guy as the IGP within the enterprise network. So within the enterprise network, if you're running the RIP protocol, EIGRP, OSPF, even the ISS protocol, it's fine. Because within the company, these are the company, within the company, if you have routers over there, if you're going to run the OSPF, EIGRP, any protocol, that's fine. Because within the company, I have my own users, right? They cannot make an attack in my network. Same thing, take example, we have another organization, they have own routers over there. So I can run with the any protocol. For example, this guy said, hey, let's run the EIGRP. Let's run the OSPF protocol. Fine. In the IGP means what? Within the enterprise, within the own company, within the own company, within the own company, if you're running the IGP protocol, that's fine. Because within the company, attacks are not possible. See, it's possible, right? If your internal employee is gonna do the attacks, but it's hard to make an attack from the outside network. But do you really think that if I'm gonna provide the connectivity between this guy to this guy through the service provider, can I run the IGP protocol over there in between the service provider to the company's network? No, because on the service provider side, what happened? We have a good user like me, and we have a bad user also like me. So the intention of the good user is what? They just want a connectivity, that's all. What is the intention of the bad user? The intention of the bad user, they can make an attack in your network. The bad user we can call as the attacker. They can make an attack in your network. So is it a good way to, is it a like a feasible way that we can enable the EIGRP on this side or the OSPF protocol? No, because both the protocol is not reliable because it's IP-based protocol. Apart from this thing, let's take example another way. The internet is a very used, right? If you have a look the picture of the internet, take example of this diagram, understand the concept. So see over there what we have. So understand this one. So this is the one router we have. This is another router we have. This is another router we have. This is another router we have. This is another. These are the routers we have over there. Understand the concept. If you go from this router, focus on this person right now. If you want to go from this router, this is the source, and this is the destination. How many paths we have? Tell me. If you see how many paths, you can see you can come via this way, to this way, to this way. You can come via this way, this way, this way, this way, this way. You can come via this way as well. You can come via this way as well. You can come via this way as well. Multiple ways we have, right? From one source to another destination. Now try to think, right? Now try to think one thing. What? How many ways we have how many ways we have to manipulate the part in the EIGRP and OSPF? Either you can change the offset list because these are not recommendation one. So how many ways we have offset list, right? How many ways we have in the OSPF? Change the cost, or maybe there are preference always. 1 and 2 or 3 max to max. But in the OSPF, in the BGP protocol, what happened if I talk about the BGP? BGP has a more than I'm talking about more than 12 ways to manipulate the path. More than 12 ways. Apart from another point, if you have a look over there, over the internet side, if I'm going to run the OSPF and EIGRP protocol, these protocols are not a scalable one because of the one of the reliability perspective. Second is what? These protocols are introduced to run within the enterprise network, because within the enterprise network, what happened? We have a 10K routes, maybe the 20K routes. That's all. 30K routes, 40K routes. So IGP protocol was designed to handle, right? It was designed to handle all about what? How many routes? 10,000, 20,000, 30,000, 40,000, but not millions of the route. BGP protocol, the first thing about the BGP is what? BGP is a TCP-based protocol. we have a reliability of it. So always between the organization, right? Between the organization, we are always gonna do the BGP. Okay, it doesn't mean that we are not running the BGP inside the company networks. We do run, right? We do run. There is some scenario is coming. We do run the BGP inside the network as well. That you will understand in the next to next class or maybe in the CCI in the very detail. But yeah, we do run the BGP under the inside network as well. But try to understand the main focus of the BGP is what to run BGP on the internet side. Reason because because this guy has a 20K routes, for example, this guy has a 30K routes. To exchange these amount route, we can only have one protocol, that's a BGP. Because BGP is a more scalable protocol to handle the millions of the route. I tell you about one story, right? I think so 3 months back, I was troubleshooting one of the network and I found almost 9.5 lakhs of route in the routing table. That was the BGP one. 9.5 lakhs. Do you really think that 9.5 lakhs is like a 1 million? Do you really think that these routes are handled by the OSPF and EIGRP? No. These routes are handled by the BGP only. Second thing, BGP is a reliable protocol because of the TCP based. So BGP is the only routing protocol that's a TCP based protocol. It's a scalable. And third point is whatever the BGP. The third point of the BGP is what we have a multiple ways to manipulate the path from one source to another destination. So if I conclude this guy now, the BGP is what? BGP is a scalable protocol. It's a reliable protocol. It's a stable protocol because of the slow, right? It's a very slow protocol, and that's a beauty part of the BGP because that's make a BGP is a more stable protocol. And it's a flexible protocol as well because we have multiple ways to manipulate the route, right? It's a only one routing protocol that's going to use the TCP one. It's only one routing protocol that use TCP. BGP is designed to run between the customer to customer and customer to the service provider. BGP is the one of the protocol, right, that can handle millions of the route, which is not handled by the other routing protocol, right? It is designed, right, IGP. So BGP comes under the EGP. EGP means what? Exterior. Have a look the name of that, exterior gateway routing protocol. While say the exterior means what? Between the companies. Whereas the OSPF, GRP, RIP protocol, that even the static route, ISS protocol, these are called what? Interior gateway routing protocol. So it is designed, right? It is designed what? It is designed within the company. So understand this way. Right? So understand this way. So exterior and interior is what? So take example, we have a one organization, we have another organization over there. So we have a routers between this guy. So we have router 1, router 2, router 3, right? We have router 1, router 2, and router 3. So between to this guy, right? What we can do that we are gonna run the any of the routing protocol, maybe the host web. Between this guy to this guy, we are gonna run any of the routing protocol, maybe the static or anything. Right? When I'm going to provide the connectivity between the Cisco to the Juniper, take example, is the two organizations we have, Cisco and Juniper. When I'm going to provide the communication between these two guys, I need a one person that's make a connectivity. That person name is a ISP service provider. So you need to take a connection with the service provider like this way. And between this guy, what we can do that we are gonna run the BGP protocol. That's why I said the exterior means what? Between the service provider and between the companies to companies. And interior means what? Inside the enterprise network. Inside the enterprise network. That's the meaning of exterior or interior. Guys, anyone has a question till this point?
Hello?
Yep.
A doubt, sir. Can you repeat again, sir?
So
You say always
exterior means what? Exterior means between the companies to the service provider, right? Interior means what? Within the company's network, we are gonna run this protocol. All this one.
okay,
That's a
sir.
name. If you focus on the name, a name is saying that exterior means what? Exterior means outside the network. Interior means what? Inside the network. All clear?
Yes, sir.
Now, if I talk about the BGP is an application layer protocol. It's a layer 7 protocol, and the BGP has two flavors. If I talk about the flavors of the BGP, so itself BGP has two protocol. So BGP is a stand for the border gateway routing protocol. Why is it the border? Because the reason to call as a border, because this is the border of this company data. This is the border of the company data, right? So between the border to the service provider, we are gonna run the BGP. Between border to the service provider, we are gonna run the BGP. This is the edge router, right, of the company. This is the edge router of the company. This could be also an edge router of the company. So on the edge router, that's called the border router, we are gonna run the BGP. So BGP has a two flavor. One is called the IBGP, right? That's called the internal BGP. And another is called the eBGP. That's called the external BGP. Right? So two flavors we have inside the BGP. So one is called the internal, another is called the external one. So if I talk about the internal, right? Internal means what? Within the same organization, or we can say that within the same organization, or we can say that within the same autonomous system number. Right? Same thing if I talk about the external BGP. So between the organization, or we can say that between the AS number. So take example. If you remember, the AS number is what? AS is a group of routers. So take example, this is the one logical domain. In this logical domain, we have a multiple group of routers, right? That is identify the one number. That number is called the AS number. Same thing, we have another group of router. This logical domain represented by the another number, that's called the AS number again. So if I talk about, right, AS number is what? It's a group of router, right? That is maintained by the single admin. Here, the meaning of single admin is what? A company. So for example, this AS number 1 is belong to the company XYZ. This AS number 2 is belong to the company ABC. So we have two different organization, right? So company XYZ, they have a AS number 1. Company ABC, they have a AS number 2. So AS number, right? It's a group of router that is maintained by the single admin. Here, the meaning of single admin means what? Let me write on this thing. AS number is stand for the autonomous system number. If you remember that we have done this part in the EIGRP protocol too, right? Autonomous system number is a group of router, is a logical group, we can call it. So you can see that this is the one logical group we have that is maintained by single administrator. Here, the meaning of administrator means what? A company. This logical domain is identified by AS number. So AS number could be, it could be 16-bit and 32-bit as well, right? So if I talk about, understand the concept. If I talk about this guy, right? If I talk about the IBGP, that's called as a BGP has a two flavor. One is called as a IBGP, another is called as a eBGP, right? So IBGP means what? Within the organization, right? eBGP means between the organization. So take example, we have a router 1, we have a router number 2, right? If they belong to the same organization, right? So I call this guy the same autonomous system number. So AS number 1. So between the router 1 to router 2, right, we are going to run the IBGP. Whereas if you see over there, this is the router number 1 we have, this is the router number 2 we have, right? So both are running with a different autonomous system number. So I call this guy the router number 1, I call this guy the router number 2. This is the AS number 1, this is the AS number 2 we have, right? So we have a link between router 1 and router 2. So if you see the connectivity we have between this guy to this guy, it's a different AS number. So between the AS number, we are going to run the eBGP. So the flavor we are going to run over there, it's called the eBGP over there because we have two different autonomous system work. So that's a basic difference, right? Or the eBGP and IBGP. If I talk about another difference, right? Of course, take example, when the router 1 has a 1.1.0.0, it will extend this route to the router number 2. Router 2 will receive it and it will add this route in the routing table with the AD value 200. Same thing when router 1 is going to extend this route to the router number 2, 1.0.0.0/8. It will exchange like a 2080. So 8020 is going to represent the eBGP, 8200 is going to represent the IBGP. So two flavors, it's got either you can call as a flavor, either you can call as the types of BGP. So we have two types of BGP. So like a OSPF, we don't have a types, right? EHRP, we don't have a types. But BGP have a types, IBGP and eBGP. So if you remember just 10 minutes back, I told you that, BGP doesn't mean that it's going to run between the companies or between the service providers, right? And over the internet, you can run the BGP inside the service provider as well, right? And inside the company as well. Which flavor you're going to run inside the company and inside the service provider? Of course, this guy. So take example, right? I'll draw this picture over here. So we have router 1, we have router 2, we have router. This is the one service provider we have, and this is the company XYZ. And in this company, we have a lot of connected over there, right? And then we have other companies we have, routers are connected over there, right? So this is the service provider. This is the company XYZ. Sorry, let's make a ABC. And I want to achieve the communication between the XYZ to the ABC. So I understand within the company network, which protocol I'm going to run. Within the company, it's an interior. Means I can go with the OSP routing protocol. Within the company, which protocol I'm going to run, I can go with any protocol, maybe the static route as well. That's fine. That's two routers. But between the company, which protocol I'm going to run, it's an eBGP flavor because it's an eBGP because it's between the two organization and between the two different AS number. Because this border router we have, this is also going to run with the BGP over there. So I can call this guy the AS number 1. This is the border router that I'm assuming right now. So this guy is going to use the AS number 2. So between the AS number and this is the service provider, of course, going to use the AS number 100. So between the service provider to the customer, or we can say that between the AS number to the AS number, I'm going to run the eBGP. Between the AS number to the AS number, we can run the eBGP, right? And of course, inside the service provider, right, you will see the multiple protocols. You will see the OSPF as well, right? You will see the IBGP as well, or maybe depend on the service provider to service provider. They are also going to run the ISS protocol as well. Okay, hold on. You will understand each and everything, but you need to have a little bit patience with the BGP. I'm frankly telling you, because it's a totally different routing protocol, right? So you have to have a little bit more patience. So spend some time, watch the video more multiple times, 2 and 3 times, and do the practicals. If you're not going to do the practicals of the BGP, you will never ever understand the BGP. Okay, so very, very important. Focus on the each lines, what I'm saying that, okay, draw the diagram in the notepad, then you will understand the BGP. It's a very tricky protocol. So can you see that what I mentioned, eBGP means what? Between the organization. So service provider, of course, this is the one organization. This is the company ABC, it's organization. So eBGP over there. Or either we can say between the ACE number. So this company is going to use the ACE number 100 and this company is going to use the ACE number 1. So eBGP. Same thing, ACE number 100 and this company is using the ACE number 2, eBGP. But within the company's network, I can run the IBGP as well. Internal BGP, we can call it, because within the same autonomous system number. Can you see that? This one, within the same autonomous system number, I can run the IBGP, or you can go with the IGP protocol as well. Depend on the requirement, right? What requirement you will understand later, not now. Okay, many things will be clear when you go with the advanced level of the stuff of the BGP protocol. So BGP is not about the CCNP. Talk about the, it's a just a foundation of the BGP. That's like a basic level of the BGP. Like I can say that only 10% of the complete BGP you have in the CCNP level. Even I'm saying the 10% is enough one, right? But I label has, CCI label has lots of BGP. Even the service provider label has lots of BGP, and BGP works differently on the every operating system. All done, man. So this is all about the BGP right now, the theory part. Now, apart from this thing, if I talk about the neighborship, like how we can form the neighborship normally in a, if you remember that, in any of the routing protocol, maybe the EIGRP1, router 1 and router 2. So how they will form the neighborship, take example. So I said the 12.1 and 12.2. So normally I just put the command router EIGRP number 1 and say the network 10.1.12.0 and say the router EIGRP number 1 and say the network 12. So normally in that case, what happened? Understand the concept. This network statement is going to enable the interface into the routing protocol. Can anyone tell me what is the use of network statement? Anyone? What is the use of network statement?
Enables the interface.
Sorry?
It enables the interface. I mean, you can
Okay,
enable the
perfect.
interface.
One, it's enable the interface. Another one.
Sorry?
Another. It's just a one definition. Another one. I wrote the three things.
Enable the interface. I don't remember the other ones. Just interface plus advertise the networks.
So it enable the interface, advertise the network, join the multicast group, right? So this is how the things
Join
are
them,
happening
that's
in
right.
the
Yeah.
IGP protocol, in the IGP like EIGRP host protocol,
Yes,
right?
that's right. Yeah.
So it's gonna enable it. So once it is gonna enable the interface, it will send the EIGRP hello packet. It will send the EIGRP hello packet. And based on the hello packet, what happened if the neighborship criteria is gonna match, it form the neighborship. That's neighborship is called the what? Dynamic neighborship. Why I call it the dynamic neighborship? Because I just put the command and everything is working automatically. That's something of dynamic. Like compare with the static routing protocol with the dynamic routing protocol. In the static routing, what happened? Everything you have to give manually. In a dynamic routing protocol, what happened? We just need to advertise. That's all. That's my job is done. So if I talk about the neighborship, the EIGRP OSPF RIP doesn't have a neighborship concept. EIGRP OSPF ISS, they are doing the dynamic neighborship. It doesn't mean that they don't have a static. They do have a static as well. But by default, they are doing the dynamic neighborship. If I talk about the BGP protocol, right? In a BGP protocol, what happened? Let me explain you this thing. IGP. IGP network statement. It enable the interface into particular routing protocol, right? It join the multicast group, depend on the routing protocol. It advertise the network. That's not a correct estimate, as I told you that as well. But yeah, just to, easy to understandable, you can do that as well. Second thing, if I talk about the BGP network statement now, see the difference in that. It just advertise the route. Why don't we have a multicast group? So BGP does not have any multicast group, right? BGP is a TCP based protocol and TCP does not support the multicast. So class D we don't have. Like a class D we have in the EIGRP OSPF, right? 224.0.9, 10, 224.0.5.6, we have it in the IGP, but we don't have this class D multicast address in the BGP. So BGP like has a unicast concept, not the multicast. So in a BGP network statement is what? It's just going to advertise the route. How we gonna, so if I'm gonna advertise the route, then how we form the neighborship? So BGP, it's like a same static route. In a BGP protocol, what happened? We need to define manual neighborship. We need to define manual neighborship. How are we going to define the manual neighborship? Based on the neighbor command. So this neighbor command enable the interface into BGP. So if you're going to put the network command, it's just going to advertise the network. If you put the neighbor command, it's going to enable the interface into the routing protocol. So in IGP protocol, what happened? This one command was advertising the route as well. Right? This one command is advertising the route as well. And enable the interface. That's going to help to form the neighborship. Why? But if you see this guy, BGP network statement, it's going to advertise the route. We have another command to enable the interface. Two different things we have in the BGP, and that's why BGP is a little bit complex protocol than the other one. So what you have to do that? First of all, you need to first form the neighborship, right? Because if your neighbor is not formed, then you cannot advertise the route. So first you have to form the neighborship, then you have to advertise the route. Right? As I mentioned that BGP is a unicast protocol. It doesn't have any multicast group. So normally BGP, as I also mentioned, that BGP is a TCP based protocol. Right? So what happened? First, the router will send the sync packet. Then router 2 will give the sync plus acknowledgement. And then router 1 will give the acknowledgement packet. And then finally, your BGP comes in the picture. Then whatever the BGP message you have, all the BGP comes in the picture. So between the routers, right, this stuff is going to happen. So when I'm going to form the neighborship between the router to router, right? So take example, we have router number 1. Copy and paste. We have router number 2. Right? So 12.1 and 12.2, understand the concept. So first what happened? between the router 1 and router 2. Doesn't matter which neighborship you're going to form. Either you're going to run with the IBGP or eBGP, right? In the both the case, what happens? It's a TCP-based protocol. So in the TCP-based protocol, what happened? I really need to exchange my three-way handshake process for TCP protocol. If the TCP handshake process is done, then our BGP comes in the picture. So which flavor we are running over there, guys? It's a eBGP because we have a two different autonomous system over there. Network statement just going to advertise the network. That's all. To form the neighborship, to enable these things, we need to use the neighbor command. So now let's have a look how we can enable the BGP. So what I can do that, I'll first show you the behavior in the paint file because it's really important. And you guys help me out. Which flavor is this? So between the router 1 and router 2. Twelve 1, 12 2. Right? Router 1, router 2. Interface we have. So this is the one organization. I can say the organization is Cisco, right? This is the another organization. So different organization is going to use the different autonomous system. So this is the AS1, same organization, same organization. So can you tell me which one is the IBGP and which one is the eBGP? Anyone?
Second one is IBGP.
Uh,
The
so
second is
AS,
IBGP.
Second
so
one is
The
same AS
packets
is
are EBGP.
IBGP
same AS is
and
IBGP.
different AS
same
is
AS is
EBGP.
eBGP, right? Same AS where I'm going to use it in the same organization, right? And different AS I'm going to use in different organization, right? So let's
Simple.
how you can enable the BGP over there. So I'd say the first command, of course, you need to go in the config terminal mode because every configuration you're going to do in the config terminal mode. Next part is what? You need to go in the config terminal mode and say, hey, listen, I'm going to enable what? I'm going to enable the which protocol? I'm going to enable, if you're going to put the question mark, you will see the bunch of protocol like OSPF, ODR, like EIGRP, right? I'm interested in the BGP now. And then it will ask you which autonomous system number you are running. So let me tell you one thing. If you have a iOS version is 12.0 iOS, then you will see the 16-bit range. If you have a 15.0 iOS version, then you will see the 32-bit range. So I'll say the ACE number is 1, right? And I say the what? If you're not enable the BGP router ID, you can also enable it manually, put the command, right? If you don't do that, then it will go with the default behavior, like what? First, manual preference. Second, if you don't give the manual, then it will go with the highest loopback interface IP address. If you don't have a loopback, then it will go with the highest physical interface IP address. So I just give the manual command. That's always recommendation 1. If you don't do that, that's fine. And then I will say that what? To enable the interface, I need to use which statement? Guys, to enable the interface, which statement? Network or neighbor? Neighbor command, right? So I said the neighbor, what? So manually, because in a BGP protocol, what happened? We need to define everything manually because it's a manual way to define the neighborship, right? So I need to tell this guy, hey, listen, I'm on the router number 1. And what I'm saying that I'm going to form the neighborship with the 12.2. So I will mention that over there 10.1.12.2, right? And 12.2, which is the router number 2, router number 2 is using the ACE number 2. So for me, understand the concept, guys, please pay attention. For me, ACE number 1 is a local ACE, right? And for me, the ACE number 2 is a remote ACE. For this guy, AS number 2 is a local AS. And for this guy is a remote AS. So right now I'm on which router? I'm on the router number 1. So I will say that neighbor 12.2 is using the remote AS number 2. Exit. Same command on a router number 2 now I have to do that. Router BGP number 2. If you want to define the router ID, you can define it. I'll say the 2.2.2.2.2. And I'll say the neighbor 12.1. The 12.1 is going to use the AS number 1. That's how you are going to enable the neighborship, manual neighborship. On data number 1, on data number 2. This is called as a eBGP direct neighborship. You will understand the meaning of eBGP direct neighborship. Hold on. Don't worry about that. Why I say the direct neighborship? Because both the neighbor, both the interface, if you see that 12.1 and 12.2 is a part of the same broadcast domain. That's why it's called as a direct neighborship. That means what? The IP addresses of the neighbor are part of the same broadcast domain.
If there is a different net, like a different subnet, then it's a different
As
domain.
different subnet as well. That's called the indirect neighborship. I'll come to the point. Hold on.
For instance, is 10.1.13.0, for instance. That's a
So
different
it is
broadcast
so
domain.
it's something like that. So take example, we have a 1.1.1.1 and this is 2.2.2.2. Different loopbacks we have. So if you're gonna find the neighborship between this guy to this guy, that's called the indirect neighborship. Because both the guys put in the same subnet right now. So it's a direct neighborship. So when the different broadcast domain is there, it's called the indirect neighborship.
But still, obviously, neighborship can establish, right?
Oh, well,
Yeah,
I'll come
of
to the
course.
point. Don't worry about that. We'll see that.
Okay.
So now we have a next part is what? If you go to this guy now, in the router BGP, I say the router BGP number 1. Right? I'm not going to define the router ID, leave it. I say the neighbor, because to enable the interface, I need to use the neighbor statement 10.1 or 12.2. Which remote AS? Now understand the concept. My local AS number and remote AS will be same. Same thing on this guy router number 2 now. So this guy also will be same. I just need to change the IP address. And that's all. So if you see the neighborship that I have between the router 1 to router 2, it's called as a iBGP. So sometimes it's called as an external neighborship as well, external link, right? And sometimes it's called as an internal link as well. The different name we have. So neighbor statement, again, I'm repeating, it's gonna enable the interface. Network statement is just gonna advertise the router. If you see, as I mentioned, it's a unicast routing protocol. We don't have a class D. So you see all day we have a unicast over the IP, class A, class B, class C. You don't see the class C IPOs over there. Guys, anyone has a question till this point in the neighborship part?
No, sir.
No, it's all good.
All good. Now, this is called as a direct neighborship. This is called as a direct neighborship. Now, one thing always remember. BGP is a TCP based protocol. And TCP is a reliable protocol, which always require reachability of IPs If you don't have reachability, then BGP neighborship never comes in the picture. So tell me one thing. You tell me one thing. Can I ping from router 1 to the this IP address 1202? Can I ping from router 1 to this guy 1202? Can I ping from router 1 to 1202?
No, sir,
No.
because our network is not advertised, sir.
Network is,
Not advertised, sir.
so we cannot ping. Anyone else?
Yeah, you can ping. They're the same, they're connected.
Thanks. Dennis, so of course we can ping. Saurabh, please revise your all videos, the CCNA level stuff. Same subnet is there. We can ping it. So we can ping it, right? Because it's a, so if you're gonna ping it, it means that we do have a reachability over there. So if you have a reachability, we can form the neighborship. Now let's take example of now I'll do one thing. I'll copy and paste. Now understand this concept. AS number 2. Now what I want, understand, we have a loop back behind the router number 1. And we have a loop back behind the router number 2. Right? Same way what happened. We have a loop back behind the router number 1. We have a loop back behind the router number 2. Right? Now, I want to form the neighborship between the loop back to loop back. I want to form the neighborship. So I'm not interested to form the neighborship between the physical interface, because physical interface can meet down, right? Physical interface can meet down, right? So I don't want to make a neighborship between the physical. I want to make the neighborship between loop back to loop back. So what I told you that if your BGP is a TCP based protocol, if you don't provide the reachability, they cannot form the neighborship. So the first thing is what? You need to give the route. So on the router number 1, I need to give the IP dot. Anything to make a reachability, understand that's very, very important. To make a reachability, you can do anything. You can make a static dot, you can make a EIGRP, you can make a RIP protocol, you can make a OSPF, you can make a ISS. To make a reachability, I just want a reachability, that's all. So I said the IP route. And next one will be and same thing on the router number 2 now. That's all. So now understand the concept. Now if I'm going to ping from router number 1 to the 2.2.2.2.2, I can send the traffic. When I'm going to ping from the router number 1 to from the 1.1.1, I can send the traffic. I have an end-to-end connectivity right now. Now I can do the BGP configuration. The first part, of course, we have a AS number 1 and AS number 2. It's a different AS number. So as the router BGP number 1, right? If you don't define the router ID, you can define it. And so neighbor will be what? Now I'm forming the neighborship, the 2.2.2. Try to understand. I'm forming the neighborship from router 1 to the 2. If I just put the command neighbor 2 and remote is right 2 over there, then what happened? My source interface, right? The source will be what? My 12.1 and destination will be what? 2.12. Am I forming the neighborship between this guy to this guy? No. By default, always remember one thing. Source will be exit interface. Always pay attention, guys. The exit interface always will be the source. But what I'm doing that, my agenda is what I have to form the neighborship between the loop back to loop back. So I need to mention over there, hey, I don't want to make a source as a 12.1. I want to make a source as a loop back number 1. I need to change the source behavior by using the command over there. Update source loop back number 1. And then lastly, neighbor 2.2.2.2, I need to change the TTL value because by default, the default TTL for the eBGP is what? Is 1 only. So understand the concept. If the packet will get out from here, sorry. If the packet is leaving from here, then what happens? It will comes to the router number 2. When it comes to router number 2, it will comes with the TTL what 1. Router 2 will accept this packet, but router 2 cannot process this packet to the different broadcast domain because now it's become the 0, right? So 0 will be dropped. So I need to change this TTL over there. I say that eBGP man, it's due to the service provider XR, right? Commands are very in my mind always. eBGP multi-hop. You can choose any number till 255, but don't choose any random number. Make a number as a requirement perspective. Otherwise, you will have an attack in your network. Okay. So that's a command for the router number 1. And same thing on the router number 2, what we have to do that. Router BGP number 2, BGP router ID will be if you don't put the 2 over there, then what happened? If you don't put if you just put the enter over there, then what happened? By default, it will take the TTL as a 255. If you don't put the any values over there. So after doing this thing, what happened? Now I will form the neighborship, and that's neighborship is called the external link. And this neighborship is called the indirect neighborship. Why I call it the indirect neighborship? Because now we have a neighborship between the 2 different broadcast domains. You may have a question, hey, Law, where is the use case of the indirect neighborship? Where is the use case? You will see that in the tomorrow lecture, don't worry. Same thing, right? I'm so sorry. Always remember, BGP needs a rituality. If you don't have a rituality, the neighborship never comes in the picture. So if I'm going to remove the static route, right? Take example, if I'm going to remove the static route, then even if you have this BGP configuration, the neighborship never comes in the picture. Same thing on the router number 1 over there, what we can do that, right? So I'll give the static route. I don't have a space over there. You can use the EIGRP as well. We'll see that tomorrow. Right, then I'll say the router VGP number one. I'll don't give the VGP router ID, so the neighbor will be same as them. Neighbors will be 2.2.2.2. Of course, I'm gonna change my source because by default the source will be what? As a exit interface. And that's all. Why we don't need to give the TTL over there? Because for the eBGP, the TTL is by default 1. For the iBGP, the TTL is by default 255. So if already the TTL is 255, then we don't need to give the TTL command over there. Now, why this thing is happening? Why there's a difference in the TTL? The reason is that because iBGP is for the internal neighborship, we can call it in the same organization. So in the same organization, there will be no attack. That's why the TTL is open. The TTL is higher. But eBGP comes in the picture between the two different organizations, between the two service provider as well. So I cannot trust the service provider, right? So I need to limit this TTL value so that attack will be mitigated. So we don't need to give the TTL value because already have a 255 as a TTL by default. Same thing on the router number 2 now, we can do that with the IP route. All done. Update source loop back number 1. Exit. So this is how you can make again, this is the internal link you have. Right? Same concept, indirect neighborship comes in the picture when you have a neighborship between the two different broadcast domains. So right now the neighborship is happening between this loop back to this loop back, like this way. I don't do that. I'll make a paint over there. Between this guy to this guy, I'm making the neighborship here to here. Same thing, I'm making another neighborship between here to here. So we don't have a physical neighborship. We have a neighborship with the virtual loop back to loop back. So in the downside, you can see that my neighborship is the immediate direct neighborship between this physical interface to this physical interface. But now we have a loop back to loop back. So I can mention over there, this is the loop back to loop back now we have. Guys, anyone has a question in the internal or external eBGP and indirect and direct neighborship BGP? Is it all clear? Anyone has a doubts in the command line anyway? All the command is clear?
No doubts, but for some reason these documents are not available on the drive, you know.
Or what? The
So-
paint file you're talking about?
Yeah, the paint file, even the previous labs.
I'll
So
check.
this,
I'll check it. If I have, I will upload it. Don't worry.
yeah, thank you so much. Videos are there, but these paint documents are not there. It's
iBGP
better
Voice
if you can't.
future.
by default TTL is 255. ABGP ABGP Really? And one thing that I'm going to write it over, it's very important. IBGP does not change the. I'll explain it this thing later. Don't worry on that. EBGP does change the next step. Wait, horizon. in an interview, don't say that number, say the AS path. I just mentioned the number in the bracket so that path is a call as a number, right? I just mentioned the path over there, but don't say the number in the interview. Just remove it. AS path is used to print the loop. We'll see that, guys, don't worry. So whatever the things that you know right now, that only the TTL value and AD value, the remaining two like a next stop and rules behavior like a split horizon and AS path will catch this thing tomorrow, right? It's a very important difference, right? See, apart from like between the two different AS number, same AS number, apart from those things, right? These are the major difference we have, IBGP and EBGP. All good, guys? Anyone has a questions?
What is the split horizon rule?
I'll come, that's why I said that this thing we'll discuss tomorrow, this one and this one we'll discuss tomorrow. This one. So first tomorrow we'll start with the lab part, this one, right? Or the direct and indirect. So my suggestion to you, what? You can try this lab in your laptop, GNS3. Even you can do this lab in your packet tracer as well. So all the commands are there, everything is there. Please do this lab. If you're not gonna do the lab, you will lose the class of the tomorrow as well, because you will never understand the tomorrow class. Understand? So it's a very important. BGP needs a very practice. It's an important protocol. If you have a good knowledge of the BGP, I'm telling you, anyone can offer you the good money. Anyone. Okay, I just explained the tomorrow. So BGP protocol, I'll tell you where you can use it. So you will see the BGP in the enterprise network. You will see the BGP in the high level BGP. You will see in the service provider network. You will see the BGP in the data center network as well. So if you're good with the BGP, then you will never face the issue in this domain, like a service provider and the data center. If you are good in the OSPF protocol, right, and ISS protocol, your service provider will become very easy. If you are good in the ISS protocol, it will be very easy for the data center and service provider. If you are very good in the multicasting quality of service MPLS, then you are good, very good. Then the things will be very easy in the service provider and data center as well. So every tracks are correlated. Only the thing is that the enterprise is the foundation. So if your foundation is not good, the another track will really become hard for you guys. I'm requesting to everybody, please do the practical of the BGP. If you're not going to do that, you will lose many things. Okay. So I'll catch you guys tomorrow, and we'll do the lab, and we'll do this thing as well. Okay. Anyone has questions?
No,
Yeah,
sir.
split horizon rule.
Oh, we'll discuss tomorrow. Nasib.
Hello, sir.
Yeah.
Sir, OSPF notepad file not upload in the Google Drive, sir.
कौन सा notepad file?
मतलब जो कॉन्फ़िगर हुआ था सर.
यार अब उसको कहाँ खोजूं मैं? एक मिनट रुको. उस पे मेरे पास this is the final text we have. I have the authentication is we are summarizing.
Okay, sir.
I'll upload this notepad file. Hey, thanks, guys. Okay, guys, I'll catch you tomorrow, and bye bye. Have a good night.
Good night, sir.
Good night. Hey, one more thing. Forget to mention that.